All right. So today we're going to talk about gears and some linkages and some mating that we can do in SketchUp with gears and a few other the mates that we can do and then the mechanical mates. So, but to start with, what I wanted to talk to you guys about is a little bit of how gears work, and because that information will be useful when you're setting up your gears so that everything meshes together correctly and so that that all of your gears turn correctly. You don't have any weird binding. So what we want to look at, and this is one of the main important things, is pitch diameter. And pitch diameter is, I drew it out here in this circle here. So let's go and we'll open up this sketch feature here and we'll edit it so you can see some of our dimensions here. So what we'd be looking at is we have two gears here, and one of them has 20 teeth, this one here, and one of them has 40 teeth. And it's just a typical arrangement. And between these two gears, from the center point to the center point, I set it up so it's 60 millimeters. And the 20 tooth gear is a module 2 gear, which means that its pitch diameter is going to be 2 times the number of teeth. So its pitch diameter is 40. This bigger gear here, the 40 tooth gear, is also a module 2, and its pitch diameter then is going to be 80, because that is 2 times 40, which is the number of teeth. We'll give it a pitch diameter of 80. And you'll notice if you look at the radius here, the radius of an 80 diameter gear or pitch diameter is going to be 40, right? Half of your diameter. And the radius of this 40 pitch diameter gear is going to be 20. So that 40 plus the 20 is going to give us the 60, which is the distance between the 2 points. And if you zoom in here, you can see that these two circles are tangent to each other. And you could also see that as the gear was spinning, the tip of your gear never impacts the root of the other gear. There's always a space in here. And basically this lets the gears spin without binding. So when I say module and tooth number, we'll get out of this edit sketch. So we'll back out of here, and we can right click on this little gear and we can go to the edit toolbox component. I've already brought these gears in. I brought them in from the toolbox. Remember, you can go to toolbox, we're dealing with metric, so you go to the metric drop down under power transmission and then gears. And that's where you can bring in your gears. And these are basic spur gears. So that means that the tooth pattern, there's no angle that the tooth is rotated at or anything like that. They're coming straight out, 90-degree angle out from the body of the gear. And here I'll show you that. If we spin around here, you can see that they don't, there's no weird pitch to them this way or anything. They're a standard spur gear that comes out from the center and radiates all the way around. So, and when I say, that it might have some sort of weird pitch to it, let me just pull in a helical gear real quick, just so you can see it. We'll zoom out. Let me click off of it. We'll zoom in on it. And you can see a helical gear, the teeth are spiraled around the shaft. So that's what I meant by a helical gear. And that's kind of a different beast, though it still has a similar setup when you're matching it with its other type of gears. You want to make sure your module is the same. So anyway, we'll exit out of that. We'll go back to this. We're going to look at just these basic spur gears for right now. We'll go normal to our front plane. All right, so we've got the small spur gear here. So if I right click on this and I edit the toolbox component, because we already brought it in, right? In here, this is a screen that you would see if you brought in a brand new spur gear. And to come in, it would have what the part is, and then you would have some properties here. The first property is the module. And like I said, that is the value that if you multiply it times the number of teeth, it's going to give you your diameter for your pitch, right? So if we go in here, we can change some of this, and you can see what happens when I change it. So say we go to that, you can see that we went to 2.5. So now we're 2.5 times the 20 teeth, and our gear got bigger, right? And you can also see, if you were to imagine these meshed up, this tooth isn't going to fit in between these teeth very well. These two teeth very well. If I was to go and make this gear a module 2.5, then the teeth would mesh, but we'd have to change the distance between our centers, because we have 20 teeth here at 2.5. That gives us, for our overall diameter is going to be 50 then, right? Because 2.5 times 20 is going to be 50. So, and which means if we were to do the same thing to this one, then we'd have to increase this distance from our center point to our center point. All right, so let's go back to the 2, right? Go back to the 2. All of our teeth match up, and they mesh all right, okay? And then there's a few other things down here. We have pressure angle. Pressure angle just changes the shape of the tooth, and there's some standard pressure angles. So you can see when I change that to a 14.5, the tooth gets a little bit, since these are the same pressure angle and module teeth, you can compare side to side. It's a little narrower at the base and a little bit more squared off. You can see you've got a little bit more squared off feature in here. And that pressure angle, changing that just it changes some of the properties of the gear, and I believe it allows for faster spinning gears, but perhaps a little less strength in the gear. So go back to the 20 on our pressure angle. So you want to keep your pressure angles the same between gears. You want to keep your module the same between gears. The difference that you're normally going to be changing is number of teeth. Okay, so now we have a few other things down here that you can fix while you're doing this. One of them is the face width. So the face width, if we spin around here, so here's our small gear again that we're affecting things here. Currently the face width is 12. Let's make it 24. And you see all that does is makes the gear wider. And one of the next examples I'm going to show you can see where I took advantage of that. So we'll put this back down to 12. We'll keep them the same. So we have 2 gears that are the same here still. And then you have, we'll spin it around flat so you can see again. You have your shaft diameter. So that's the shaft that's going to go into the inside of the gear. Currently it's 20. Let's go a little smaller since this is a small gear anyway. Let's go 15. You see that made that shaft smaller. So it's 15 millimeters for the diameter of the shaft. Let's go back to 20. And just keep everything kind of the same as what it was. And then you have the option of putting a keyway in here. A keyway is a way that you can lock that gear to a shaft. So here's a square keyway. You can imagine that the shaft would come through and would have a similar notch in it. And you would have a piece of metal that fit into both those notches to lock it. Or the shaft would actually have this keyway would be an integral part of that shaft. So it would be round all the way around, and then it would have this square part that's stuck out of it. And when the gear slipped onto that shaft, that would keep the gear from spinning free on the shaft. It would hold it in place. For right now, we're going to just go back to none as well. Okay, and then the final thing that we can look at is you might not have a gear that needs to be around. You may only need 10 teeth on that gear. And of course, it flipped it that way because why not? I mean, that doesn't really matter. You would imagine it would be meshed up on this side. And once you're done selecting everything, you can free spin these so that you have them around to where they need to be. But maybe this is a gear that is on something that oscillates and just rotates, half the spin So 180 degrees, just back and forth, or you know, maybe it's hooked up to a lever that cranks over, and that spins the big gear a certain number of degrees. And of course, since this is a 2-to-1, it will spin this one half the way, so you only get a quarter turn out of this gear here. So, because we're 40 teeth and we're 10 teeth. So we'll go back to the total 20 teeth. All right. So we're back to there. So that's how that gear is set up. Now, what I want to show you next is how to get these gears so that they spin in relationship to each other. And I've already done a few mating processes here, and this was to get the gears all lined up correctly. So one of the ones that I did is I did a mate where I had the face of this small gear and I mated it to the front plane. And then I did the same thing with the big gear. I took the face of the big gear and made it to the front plane. That made them so they both line up flat together along with the front plane. You can see the front plane there. I drew in a line that was the distance that I wanted between the two center points. And I did a coincidence with the center axle or the center axis of the small gear. And this happens to be the origin, but it's one point at the end of the line. And I did the same thing with this one where I have the center axis and the end point of that line. And then that keeps it so that it, you know, even though it's flat on that front plane, it can't go up and down or left and right. It stays where it's at. This perpendicular one is actually not necessary. I was messing around with a few things, and this one we can go in and delete it. It does not actually do anything anymore. It makes it overdefined. So basically with those 4 mates, we're able to, and those are just general mates, we're able to align these gears and get them set up in a position where they're in the right relationship to each other. Now, the one thing you want to make sure before you do this next step is you want to zoom in here and let's go normal to our front plane. So we're looking at everything straight on. You want to make sure that the gears aren't overlapped with each other at all. So say in this case, if it looked like that, you'd want to come down here and spin it so that they weren't touching each other. All right, so we'll click off of that. So we want to go to assembly and we want to do a mate. Now what we want to do is we want to go down to these mechanical mates. And in the mechanical mates, we have a few things. We've got cams, slots, hinges, gears, which we're going to use, rack and pinion, which is basically a different setup of gear. It takes a circular motion and turns it into a linear motion, screws, and a universal joint. So we're going to do a gear mate here. And what you want to do is we'll spin across here. You want to choose the inside of your gear and the inside of our gear. All right. And it's asking for a gear ratio. So we chose our big one first. So that's going to be the first number here. And then this other one is our small one, right? So what we want to do is it's either got your teeth or your diameter. So we know that we have 40 teeth on here, right? We also know that our pitch diameter, you can use pitch diameter as well. Basically, as long as the ratio is correct, this will work. So our pitch diameter is 80, and our pitch diameter on this one was 40, right? Because we're module 2, we have 20 teeth and 40 teeth. So let's just go with that. We'll put it in here, we'll put 80. And then this one, we'll put 40. And we'll say enter. All right. And we should be good there. So we can spin it a little bit and see how it looks before we get out of the mate. That looks good. All right. So then we say okay. And we say okay again. So if we go normal to the front plane again, we can look at this and here we go. As this spins, you can see that that your tip of your gear never your tooth never impacts the far end of the root. And as it moves across, it pushes the other gear down. And if you wanted this to be just a little bit more detailed when you were doing this assembly, you could have slid them up so that these two lines were just barely touching. Because like right now, as I spin this gear, hold on a second. But as I spin these gears, you can see that there's a little bit of an air gap in there. And that just happens to be just the way when I was lining these gears up. Because it's not actually it's not necessarily imitating a mechanical feature where you have a contact point there. You just set it up as two gears, gave them the ratio. So they know that if this gear spins at a certain speed, that this gear is going to have to spin at twice that speed. Same thing, if you were going the other way, if you were putting the motor to this one would spin at, say, 1 revolution per 10 seconds. This bigger gear would spin at half a revolution per 10 seconds. So that's how you set that up. And I have another diagram here that I can show you guys, or another model that I can show you guys that kind of explains that. So if you look at this here, we'll go to the first motion study I set up. This is not 100% what I wanted. I had some different textures on here. So hold on a second and I will, I'll put those. Okay, so I went in and I changed some of the textures here. The checker pattern made it kind of hard to see. And I had adjusted that, and then when I had clicked back on something, it had actually pulled those off. So we have a little bit of different texture here, so you can see, you can visualize some spinning here. So in this motion study 1, what I did is I set a motor up, and you can see here, if I go to the rotary motor, I click on it, and we can go to edit feature. It's a rotary motor. It has got a speed of 10 rotations per minute, and it's applied to this little gear, okay? So if we go in here and we click play, you can see that we have this gear spinning at 10 rotations per minute. Let me actually expand the time out up to this, maybe 12 seconds. All right, so you can see it's spinning. A little choppy here because it's doing its progression here. If we play it from the beginning now. All right, so we're spinning relatively slow here, right? 10 rotations per minute. But over here on this gear, it's spinning even slower. And on this medium-sized gear spins a little bit faster than the big gear. I'll play that again one last time. All right, and this is what I was talking about, where if your ratio here, for every time this one spins, it spins this other one a certain other percentage. And we can go in here and we can look, this little gear here. If we go into edit toolbox component, we see that it's a module 2. They're all going to be module 2. It has 40 teeth, okay? This medium-sized gear, we'll go in here and look, it's got 60 teeth. So it's 1.5 the smaller gear, right? And then our large gear has got 80 teeth. So essentially what that means is for every rotation of this gear here, you will get half a rotation for this big one, and you'll get 3/4 of a rotation for this little one. or 2/3 of a rotation for this medium-sized one. So let's watch that one again, and you can see this. So you see that this gear is going a little faster. This one's going pretty slow, right? And you can see by paying attention to the line. All right, so in the second motion study, what I did is, let's zoom in a little bit here so we can see it, and we will make our perspective better. And of course, as soon as I click play, it's going to zoom all the way out again, but we'll zoom back in. All right, you can see here that what I did is I put the motor, instead of on this little gear, I put it on this big gear. And so now this big gear, if we go in and we look at our motor features, we have a motor driving this big gear. It's also going at 10 rotations per minute. But now it's driving, for every rotation of this, we're getting 2 rotations of this gear, and we're getting 1.5 rotations of this little gear, of this medium-sized gear. So watch that again. Right? So when you're setting these things up, if you're going for an end result, for starters, you need to make sure that you get your gear rotations correctly when you're doing your gear mating. But then you also, when you're driving these systems, if you want a certain speed, you need to make sure that your speed association when you're doing these motion studies is associated with the correct gear, because that's going to change how all your other speeds are related. And so when we do the homework for this, I'm going to have you guys set up a few gears onto a plate. And as you saw in the first example that I showed, you don't need to do a whole plate for this, right? You just need something to give the gears rotate or relationship to each other, so that when you go and spin them, they don't go all wonky on you. Because if you didn't do that, the gears would start to, as you spun them, especially by hand, once you had them set up in the motion study, it'd be different. But when you're spinning them by hand, when they're free floating, if they don't have any relationship to each other, then they'd get out of alignment from each other. So by setting up by doing your mates where you mate them to the same plane and you get the relationship to each other correct, then you don't have to worry about that as much. Then you don't have that same problem. So, but this is just a hypothetical. If you were putting something into an assembly, this plate here would be something that, potentially you would have in that assembly, and each one of these pins would then carry these gears. So, but I'll have you set up something. I'll probably actually have you make a plate. And keep in mind, when you're doing this, I won't give you all of the values for what I'll tell you what your module for your gears need to be, but I might not tell you how many teeth you need to have, but I will tell you the distance from this point to this point. Or I might do it the other way around, where I tell you how many teeth you have and don't give you the distance from this point to this point. So you'll have to think about that a little bit when you're doing the assignment, and figure out how to fix it so that those distances are correct, so that you have your pitch diameter correctly. And do you remember when I said that I messed around a little bit with the gear width to make this part work? Well, the way I did that is, if you look at this from the side, I actually stacked my gears. So this gear with the 60 teeth is sitting below the gear with the 80 teeth, and both of them are connected to this gear with 40 teeth. And to do that, I made this gear with 40 teeth twice as wide, so that, and you can see there that you have contact along both points there. So, and if you're driving this gear, then it's just going to drive both of them. But say this gear is driven, then it's going to drive this one, and this one's going to drive that one. So That's one way that you can do that. And in some cases, you may see gears that are stacked on top of each other and they're connected, and you'll have a smaller gear inside and then another gear that sits on top of this one that contacts that smaller gear. So every time you get a rotation here, you get less of a rotation on the little one, which is going to give a different rotation out to the other gear. And that's how you would do, say, a speed reducer or a speed increasing gear set. So you can look at that for the homework. And then I want to show you one more thing. Since we didn't go over this in class, I probably won't put it into the homework, but it's another one of the mechanical mate setups that we did. And this one's pretty simple. So I figured I'd throw it into the video. I'll talk about it quick in class when we have class on Wednesday, but I'm not going to put this into any of your assignments. And what this is two pieces, right? And you remember when we had the mechanical mates, one of the mechanical mate options, here we'll open this up, is edit that feature, is one of the mate options is slot. And in slot, what you can do is you can choose two faces here. So you have the face of the slot and then the face of a pin that rides in that slot. So let me show you what the two pieces look like. So the two pieces that I made are pretty simple. It's just this plate here, right? It's got a pin that comes up and it's got a slot cut in. This pin is set at the center of, if you were to draw this circle out. So it's set at the hinge, basically the rotational point for this slot that's cut into the plate. And then my other part is a lever, and the lever has a hole in it, same diameter that pin was, and a pin on it that is the same diameter as the slot. And then the distance between these two are from the center of that slot to the center of the pin on the other piece. And so when you combine all those together, we did a few mates, right? So we did a concentric mate with this pin here and the center hole of the lever. So we made those concentric to each other, which means they're going to line up perfectly. And then I did a mate where I made the bottom of my lever mate to the surface of the plate so that those two came down and were touching each other. And then I did a slot mate, which mates this slot that we cut. And here, if I zoom in a little bit, you can see it here. And so the slot mate is a mate of this slot with the face of that pin. And what that allows us to do, if I go back to the top plane and go normal to that, I'll scroll over a little bit. What that allows us to do is we can take this back to our perspective so it looks right. We can take this lever, and this lever rides in that slot. But if you didn't have that slot mate in there and you did the concentric and the coincidence mates, but you didn't have the slot mate, you could rotate this all the way around. The mechanics of the program wouldn't recognize that pin is actually hitting into this plate at all. But because we put in that mate, then it knows that pin needs to stay in that slot. So that would have been another mate when we did for assignment 4, when you guys did the dovetail that slid into the slot. If we had done a slot mate for that one, then when you slid your dovetail all the way back, once it hit the back side of that slot, it would stop. We just weren't there yet, so we didn't add that in as a mate. So this is a slot mate. Like I said, I'll talk about that a little bit more in class, and how you can use it. And you can imagine how this would be useful, and how, if you think about some components to tools or whatever that you might have around the house, like a speed selector or something like that needs to ride inside of a slot, and then perhaps there's a gear here that affects something else in the machine. So So we'll go over that. We'll look at some of those things. I'll post up your homework for the gears, and we'll go over the gears. I know this was pretty quick and light, but there's a lot of information in there. And once you start kind of messing around with the gears, you'll start seeing that. But you can mess around with a lot of stuff. It's pretty straightforward, but it can get a little confusing. So we'll keep it a little light for this week. Anyway, I hope you guys have a good evening, and we'll talk to you on Wednesday.